Hey guys, welcome back to my channel and I hope you all are doing good. Today we are going to start another lead code problem that is boards to save people. It is a medium level question. Let's read the problem. You are given an array people where people I is the weight of the ith person and an infinite number of boards where each board can carry a maximum weight of limit. Each boat carries at most two people at the same time, provided the sum of the weight of those people is at the most limit. Return the minimum number of boats to carry every given person. So we will be given a people array in which weights will be given. So for example, this is our array. Here 3 is the weight of the first person, 2 is the weight for the second person, and 1 is the weight for the fourth person. And we will also be given a weight limit for the boat in which these people will be carried. So either we can send person with weight less than or equal to the boat capacity. Look at this example. Here our limit is 3. First person whose weight is 3 will need 1 boat. Then we have 2 comma 1. 2 plus 1 is 3. So 2 people can go in 1 boat. And another person with weight 2 will also need another boat. So in total there will be 3 boats needed to carry these people. Initially, your train of thoughts after looking at these example test cases can be that we will solve this problem by sorting the people array and then iterating over it. So I have taken an example where each index represent the weight, and I have a limit which is equals to 5. I'll keep a check on sum and the boat count. So initialize them as sum equals to 0 and boat count equals to 0. At index I equals to 0, my weight is 1, which is less than my limit. So we will add it to our sum. Now 1 is less than our limit. Hence we will increase our index to check whether more people can be carried or not. So at index I equals to 1, the weight is 2. I will add it to my sum. So 2 plus 1 equals to 3. 3 is less than 5, yes. So I'll move forward. Index 2, the weight is 3. When I add it to my sum, it becomes 5. So it exceeds the limit. Therefore, I will increment my boat and reset my sum variable to 3. Now 3 is less than 5, yes it is. So I will increment my index. Now at index I, my weight is 4. So 4 plus 3 is 7, which is greater than 5. So I will increment my boat count and again reset sum as 4. Increment my boat count. But I'll say this approach is wrong. We have got our count as 3, but I'll show still a possibility to minimize this count. Intuition behind this problem is to maximize the number of people by minimizing the number of boats used. We can sort the array of people in non-decreasing order and then use a two-pointer approach. We start by initializing 2 pointers, L at the beginning of the array and H at the end of the array. Since it is mentioned in the question itself that the weight of the people will be less than or equal to our limit, therefore the value at which the H is pointing will be less than or equal to limit. Then we check if the sum of the weight of the pointers is equal to or less than our limit. If it is so, then we can save both of them using one boat. We'll move both the pointers inwards. L will be incremented and H will be decremented. Suppose I have taken another example where my limit is equals to 5 and I have sorted the people array, and I try to find the sum of the weights of the people pointed by these two pointers. We notice that the sum is greater than the limit. 5 plus 3 is 8, it is greater than 5. So what I will do, I will consider that the end person needs one boat to carry him, and I will then decrement the end pointer. As we know that the array is sorted and the weights are less than the limit, so there will be no such weights greater than our limit. The end weight will always be less than equal to our limit. Hence, one vote is required for that person. Overall, what we want to do is pair up the heaviest person with the least heaviest person if it is possible. So now let's get back to our older example where this 1, 2, 3, 4 was my people array, and I have decremented my h pointer and incremented my l. The sum of the weight of the people pointed by these two pointers is 5. 5 is equal to the limit. Therefore, we will increment the boat count and then decrement h and increment l. This is the state when our loop will actually stop, because our loop will be running for the condition where L will be less than H. As soon as the H becomes smaller than L, it indicates that the weight has been visited. Start the coding part. I'll initialize boat underscore count as 0. Then I'll also initialize sum as 0 and another variable called L equals to 0 and H equals to people dot size minus 1. Now we will sort the vector, loop over the array. So our condition is L is less than H. If the statement is true, then we will increment L plus plus and decrement our H pointer. After that, we will increase the count of the boat. We will only decrement our H point and increase the count of the boat. This is for the condition when L is less than H. What will happen when L is equal to our H? I'll show you the example. Look at this example. We have sorted the people array and declared two pointers L and H. When we found the sum, it was greater than our limit. So what we did? We decremented our H. Our L was still pointing to the same index, but we decremented our H. Why? So that a boat is considered for this person. Next, our pointer is pointing to 3 and 4. So what is the sum? It's 7, which is again greater than 5. So we will again decrement our H. We will let a boat carry the person with weight 4. Now 3 plus 3 is 6. This is also greater than our 5. So we will let another boat to carry the person with weight 3. Now both the pointers are pointing at the same weight. When the pointer will be pointing at the same weight, that means there is no other weight left to pair with it. So this person will alone go in a boat. Therefore, if L is equals to H, we will increase our boat count. And now return boat underscore count. Here we see that h minus minus and both underscore count are both repeated in if and else statement. So what we will do, we will remove these lines. Now let's run the code. Let's submit it. All the test cases have been passed. The time complexity of this problem is n log n.